In this presentation, we will be presenting our work, PicMe, supporting personalizing products with stylized head portraits for self-expression. This work is in collaboration with Professor Yechun, Peng, Shengqi, Nanxuan Zhao, and Professor Nanxuan. Product personalization describes a process that changes the appearance or functionality of a product to increase its personal relevance and distinction. The motivations for product personalization are related to the human desire for self-expression. For example, many handbag companies allow customers to select the leather type, color, size, and other design components when ordering a bag. The customers can even have their initials or name engraved on a metal badge on the bag. Through this act of self-expression, they can convey their individuality, gain positive attention, establish social bonds, and satisfy creative urges. Researchers in the SIGCHI community have explored various approaches to self-expression by embedding personal data onto the appearance, or within the functionality of physical products. However, recent studies mostly focus on expressing abstract personal data, like bicycle riding history data, heart rate data, and environmental sound data. Exploring self-expression with non-abstract personal data such as head portraits, an important visual representation of individual identity, has received limited attention. Embedding such personal data onto the appearance of physical products raises key considerations around both designing and generating head portraits. First, it is unclear what factors should be considered when designing head portraits, such as the artistic style and emotional tone of a portrait. Second, how to automate the process of designing stylized head portraits remains a challenge. Recent advances in artificial intelligence such as neural style transfer enable rendering specific artistic styles. However, these models struggle when the domain gap between the source and target is especially large. Motivated by these challenges, we developed PicMe, a design support tool that helps users personalize products with stylized head portraits for self-expression, using a deep learning-based algorithm. Specifically, PicMe allows users to upload a face photo, interactively generate stylized vector portraits with embellishments, and preview the portraits printed on products. The user interface of PicMe is composed of 3 pages: the portrait generation page, the scene selection page, and the product preview page. The portrait generation page provides the suggestion panel to display stylized head portraits suggested by PicMe. In the scene selection page, the options panel lists options for specifying a product for printing the resulting head portrait as well as a scene for embellishing the portrait. The product preview page contains the style panel, which allows users to change the print rendition such as the size, rotation, and location of the portrait. To give a quick glimpse on how PicMe works in action, I'll be presenting a demo illustrating how user Alice uses PicMe to personalize her product.
Let's follow Alice, who is interested in personalized product customization and uses PicMe to successfully print her head portrait on her sports possession. Initially, Alice turns on the camera to capture a selfie, which is then uploaded to the portrait generation page. If she is dissatisfied with the photo, she can click Reload button to re-upload another photo. Then, Alice clicks the Generate button to instigate the system to synthesize a series of head portraits based on the source photograph. Alice can select one satisfactory result to constitute her personalized head portrait or click the Show More button to regenerate more results. After deciding the head portrait, Alice clicks the Next button to go to the scene selection page. On the scene selection page, Alice chooses an appropriate scenario to complement her stylized portrait. First, she envisions potential real-world applications for her portrait, such as sport, and clicks the corresponding area in the options panel. Next, Alice chooses her preferred product and scene that displayed on the panel under sport. She selects a hoodie from the given products and determines to use the full of energy scene because it can better reflect her state during sports activities. After determined the product and scene, she clicks the Next button to go to the product preview page. On the product preview page, PicMe renders a preview of the product across different scales and positions. Alice can choose different styles to print on. After determining the final configuration, Alice clicks the Export button, and two image files come out: a product sample image in PNG format and a portrait image in SVG format. Alice can use those images to customize her product.
First, we conducted user interviews and designer interviews to derive a set of design requirements for PicMe. We conducted workshops, collected data, and designed algorithms to address the design requirements. Our approach to generating stylized head portraits that satisfy the design requirements requires a vector-based illustration dataset that features a cartoonish and minimalistic style as the training dataset. Thus, we compared different open-source datasets that fall into this category, and selected OpenPeeps as the base of our training dataset. We also extended the dataset with more illustrations of embellishments and facial features through a design workshop and data collection. In the design workshop, participants collaborated on Figma to list physical products that they would like their head portrait printed on, categorize the above products based on their usage scenarios, and draw potential scenes which can be used to embellish the portrait. From the result, we identified 6 distinctive scenarios with 30 scenes, including work, study, sport, home, gift, and outdoor, with a set of common products. Then, we recruited designers to draw decorative scenes based on the 6 identified scenarios, and collected 28 new hairstyles, 8 facial expressions, 8 glasses, 8 beards. In total, the whole dataset can result in more than 1 million face illustrations. The style transfer from face photo to cartoon illustrations poses 2 challenges. First, correctly aligning attributes such as facial features and accessories between the 2 distinctive domains is challenging, since as illustrations are more abstract than photos. Second, compared to large-scale face photos, face illustrations are far fewer in quantity. Thus, it is difficult to construct a large-scale paired photo illustration dataset as the training dataset for AI models. Given a face photo uploaded by the user, the objective of the algorithm is to combine the content of the source with the artistic style of OpenPeeps illustrations. We designed an algorithm that is composed of 4 modules: an estimator, a combiner, an encoder, and a searcher engine. The estimator is used to provide a rough estimate of the cartoonish features included in the source face photo by generating a raw portrait bitmap. In this process, we followed the pix-to-pix method and implemented the estimator by training a neural network, where image translation was achieved using the U-net. The combiner aims to combine the components from the dataset as face illustrations and render the results as bitmaps, which will be further used in the encoding process. We standardized components, and selected one component from each category and combined them in a predefined sequence, which resulted in more than 1 million face illustrations. The encoder encodes the source face photo I original, the raw portrait bitmap I intermediate, and face illustration bitmap SIGCHI into the same latent space for subsequent search. Specifically, we utilized the pre-trained image encoder of contrastive language image pre-training to encode the images to latent codes and use the pre-trained image embedding space of clip as the latent space. The search engine is used to find a set of face illustrations from L1 to Ln that best match the source face photo in the latent space. During the process, the face illustration with the minimum loss is selected and recommended to users. We performed 2 experiments to validate the effectiveness and generalizability of our algorithm. In Experiment 1, the ablation study replaced the estimator, the encoder, and the search engine, to understand the contribution of the modules to the overall performance of our algorithm. Each of the 3 modules was replaced with 1 or more baselines, respectively. We found that our algorithm can generate results with similar features to the sources. In Experiment 2, we chose 2 alternative datasets and trained our algorithm independently on these datasets, using the same experimental settings as for the OpenPeeps dataset. We observed that our algorithm effectively matches components, including hairstyles and facial expressions, and also pays attention to the color-related features of source face photos without specialized adaptations for skin tone or hair color. To evaluate the effect of PicMe on supporting product personalization and augmenting self-expression, we conducted a user study with 40 participants. We set up a booth at a community exhibition for 15 days to showcase the work. Informational posters introduced the work while on-site computers provided interactive demonstrations, inviting the use of PicMe. The user study consists of 3 sessions: the design, fabrication, and usage sessions. In the design session, the participants were instructed to generate stylized head portraits with PicMe using their own face photos. In fabrication session, we utilized a range of printing techniques to print portraits on products with diverse materials and mailed the products to the respective participants. 6 months after the participants received the products, we sent emails to them to investigate their usage experiences and asked them to take part in a follow-up interview. In terms of qualitative results, most participants believe that PicMe can support self-expression by personalizing products. The majority of the participants agreed that the resulting head portraits are similar to their uploaded photos, described the portraits as expressive and interesting, and had a strong sense of identification with the generated head portraits. In terms of qualitative results, most participants believe that PicMe can support self-expression by personalizing products. The majority of the participants agreed that the resulting head portraits are similar to their uploaded photos, described the portraits as expressive and interesting, and had a strong sense of identification with the generated head portraits. They also appraised PicMe for its capability to support product personalization in a user-friendly manner, provide users with various options to help them create personalized products, and provide inspiration during personalization, in terms of both content and workflow with the generated head portraits. Our observations also indicate that personalized products have the potential to assist users in garnering positive attention, obtaining acknowledgement, and forming social bonds between themselves and others. Also, interpersonal understanding can be enhanced through the insight of users' personalized products. To conclude, our work contributes an interactive design support tool, a deep learning-based algorithm, and a controlled user study with 40 participants. That ends my presentation. Thank you for your attention. We encourage you to visit our website and make your own personalized product.